Alright, welcome back. This is part 2 of the 3-part series of converting the Z-Axis accessory for the old and outdated Osmo Plus camera and adapting it to work with the Pocket series of cameras. In this case, it's the Pocket 3. Now in part 1, we made an aluminum insert that goes into this plastic cap that came with the Z-Axis, and it basically adds a threaded mounting point, primary mounting point, while at the same time adding some rigidity to an otherwise weak plastic cap. And in part 2 here, I plan to make a side bracket that will screw into that aluminum insert and provide a link for the pocket camera, something like that. As you can see, I'm planning to also make it a 2-piece link side bracket. The reason there is so that just for in case I ever need to tilt this up. I kind of doubt that I'll ever need to run it in the full missionary or doggy style position there, horizontal there like that, but I think probably more commonly I might just have to tilt it slightly up to be able to see the display a little bit easier, while at the same time having this camera in a more optimal vertical L-shaped position there. It also allowed me to make the top half a little bit more robust and kind of complement the aluminum insert inside there and provide a better, more rigidity again, sandwich effect to the plastic cap. Also, if I ever need to change the length, it could be that maybe this is going to be down too far low and maybe the screen's going to be hitting the frame here, and I might have to adjust it up or down. It'll be a lot easier to do that if I just have to change this simple link rather than probably the more complex upper section here. And this link again could be quite a bit lighter than the upper section, lighter duty, to save some weight there. Or if they ever come out with the Osmo Pocket 4, maybe it's going to be a full frame with some optical zoom and adjustable aperture. It's probably going to be a little bit bigger, different size, who knows what, but again, it'd be a lot easier just to change that lower link if it's still within the weight limitations of this Z-Axis. So yeah, so let's go ahead and get started making this bracket. Starting with the upper half of the 2-piece side bracket. This actually turned out to be a complete failure, so I'm just going to go ahead and fast forward through the most of this. But for a quick rundown, basically I started with some 1/4 by 1.5" 70-75 flat bar. I drilled a 1/4 inch hole in it, machined a radius on the outside, no issues there. But when it came to putting a 90-degree bend in it, that's kind of where the failure started. I've had good success with bending 60-61 aluminum just by simply heating it up with a torch and just bending it. But for some reason, doing the same process with the 70-75, it bent real easy. Really no effort to bend it. But as you can see, the material on the outside of that bend was just really highly separated, and it probably would have held anything that this Z-Axis would hold weight-wise, but it just looked like hell. So I decided to abandon this method and try a plan B. And that plan would be to make it out of a 2x4. No, not a piece of wood, but rather 1/4 wall aluminum tubing, probably 6061, but since I could find no identifying label on the stock material itself, I can't really say that for sure. This is probably a better way of getting the starter piece I need anyways. This aluminum tubing is manufactured using an extrusion method, therefore the corners are going to be sharper, more consistent thickness, less deformation, and probably less residual stress in the corners than the previous method I failed at, which was bending the 7075 flat bar. An even more ideal material choice would have been simple angle, but since I had none in the dimensions I needed, I'm simply using what I have here on hand. Here in the bandsaw, I'm cutting the length to about 1 9/16. Fly cutting the saw cut ends to a final length of 1.5 inches, and so that they are parallel with each other. Later, I will need to grip that surface between the jaws in this vise for further machining operations. Unlike a typical bench vise like this 8-inch Wilton, the movable jaw in a milling machine vise has much less latitude for self-alignment on parts that are not perfectly parallel. Clamping onto a non-parallel part in a milling machine vise means you are only applying force to the high points. Without shimming the low points for a wider contact surface, or a secondary holding device could result in the part pivoting in the vise during the machining process. In this case, simply making the ends parallel now saves a lot of hassle. The cutting bit I am using here is high-speed steel, which works just fine for aluminum. It stays sharp for a long time, and the surface finish is good. Using this bit for cutting steel would be a different story. But even carbide does not seem to stay sharp for very long when fly cutting steel. It seems every time I grab a hacksaw, I'm reminded of a time when that's all I had for cutting out metal. We didn't have a bandsaw or any abrasive chop saw, no torch or plasma cutter, not even an angle grinder, just a hacksaw and a bunch of blades to burn up. Actually, I take that back. For heavier, thicker steel, I would crank up the old buzzbox welder to full and find whatever welding rod I had laying around and essentially just melt it right through there. Of course, I left a pretty wide kerf and a real hideous looking end to it, so I spent a lot of time on the old 6-inch bench grinder to doll that up. But yeah, poor people, poor ways. So what I'm doing here is essentially converting the rectangular tube into a piece of angle. What will be the side, I'm cutting that out to 1 7/8, and what's going to be the top, I'm rough cutting that out to 1 3/4. Back on the mill again, and we're using a 1/2 inch high-speed steel end mill to cut a 3/4 inch radius along what would be the top section of the angle bracket. After moving the angle bracket in closer towards the midpoint of the vise for more stability, we can now drill a 1/4 inch hole in the top with its center at the same center as the 3/4 inch radius we just cut. This will allow a 1/4 28 volt to go through and into the aluminum insert we made in the previous video. Alright, fly cutter again. This time it's loaded with a 3/8 bit with a hand ground full radius on the end. Essentially it'll cut a 3/16 radius. And the goal here is to just shave some weight off the top. I'll be going around most of the perimeter at a depth of about 1/8, which would be about half the thickness of the material there, but still leave full thickness over there at the angle and about 5/8 diameter, kind of an island towards the middle at full thickness. So yeah, just to shave some weight off here. The part is now rotated to where the side is up and we're on the right side of the vise again. This is another weight shaving operation. We'll be using a 3/16 end mill, and we're going to be narrowing what would be the lower section of the side. We'll be narrowing it to about 1 inch and a length from the bottom of about 1/2 inch, and we'll be kind of tapering that off back up to the full 1.5 inch width again, and there will be several little radiuses to cut the corners along the way, and at the same time we'll be shaving the hacksaw cut there at the very bottom to trim it to clean. Okay, I got the part repositioned closer to the middle of the vise to make it a little more stable. And I'm going to cut out a section in the middle, kind of a square, rectangular shaped section. But first I'm going to drill out the center, just kind of make it easier for the end mill to go in there and do its job. Using a 3/16 end mill again to shave out some more weight by cutting a 3/4 by 1 1/8 window out of the middle. This will also allow the bracket to hug a little bit closer to the upper portion of the Z-axis. Taking a spring pass here. Drilling and tapping 3 holes now. They will function as the mounting point for the lower segment bracket that I haven't made yet. The middle hole will be a 1/4 20, and honestly, it will probably be the only hole I will need. If for some reason that bolt wants to come loose and allow the lower segment bracket to lose its set, then I can use the outer holes to bolt to. They will be a little smaller at size 1032 thread. Of course, if I end up using these outer holes, then I will need to slot the corresponding holes in the lower segment bracket at a radius if I still want it to have the pivot adjustment ability that using the middle bolt alone provides. But I'm not going to worry about that now. The only reason I am doing the outer holes in this upper bracket at this time is because it's already set up in a mill and ready to drill and tap. At the very least, the outer holes will serve as more weight shaving, although I do admit that will be very minimal. While I still have the part located here, I'm just going to go ahead and put a chamfer in that rectangular window using the same bit that I used to chamfer the 3 holes. And using the same program I used to cut out the window, just a little different Z-axis position. Okay, the next step is I gotta cut some material out of here to make room for this collar so that it goes all the way up against as far in here as I can. As you can see, it's not centered yet. So yeah, this part, this largest diameter here, it's 1 5/8, 1.625. This bottom part is like 1.575, and I might have to have a stepped section here because I might have cut too much out of this here if I'm going to be cutting in these edges here, so I might make it pretty thin. I probably should have left more material, maybe come out here and not have quite this radius in here, but too late now. So yeah, so I'm just going to go ahead and set a bit for cutting. I'm going to have to cut the bottom here just to square it up and go in, because a tiny little step here I left to face off with the rest of this material, and then I'll have to move up as I come out to make that 1 5/8 diameter of this collar at least. And there is looks like about a 45-degree angle on here, so I can maybe make advantage of that too, take advantage of that, and not have to cut up into the threads. So yeah, just a little bad designing there. Preparing to set up the boring head to cut a 13/16 radius to match the 1 5/8 diameter of the DJI Z-Axis top mount area. I am just using the edge of the vise to make it a temporary 0 position. Touching off with a 1/2 inch diameter edge finder, and since we are on the right side of the vise, we will enter this current position as 0.25 positive on the DRO, which would make the actual edge of the vise 0. Remove the drill chuck and install the boring head assembly. And now we will move further in the positive X direction until the DRO reads 0.8125 or 13/16, which will be the distance from the edge of the vise to the center of the spindle. Now just touching off the cutting bit itself by adjusting the boring head, while at the same time rotating the spindle slightly to make sure that the tip of the bit is as close to the left side quadrant as possible. Since the cutting bit can slide back and forth in the boring bar itself, I really didn't need the boring head for this job. I could have used a collet to hold the bar and the spindle and simply slid the bit over until it made contact with the edge of the vise and locked it down there. I have roughed out bores like that before, and since the bar is a lot closer to the bearings in the spindle, fairly heavy cuts can be made with less machine flexing and chatter. Alright, lock the head down there, and theoretically, if I was to bore with it now, it should cut somewhere in the vicinity of a 1 5/8 diameter hole. I'll be doing two operations with one tool here. First, fly cut the horizontal surface to clean. Since the part is only 1.5 inches wide, and I am cutting at a diameter 1 5/8, there should be plenty of overlap there, even after taking into account the slight radius on the tip of the cutting bit. I will keep feeding in until the spindle is centered with the 1/4 inch hole at the bottom. In order to do so, I must cut into the vertical side and then slowly raise the bar up in multiple passes to provide the radius clearance for the DJI mounting cap area. I was unaware at the time of the potential conflict, but the diameter of the boring bar itself is 1 1/8. The distance from the face where the 3 threaded holes are to the center line of the 1/4 inch hole at the bottom is 9/16, or half the diameter of the boring bar. So in order to achieve my goal with this setup, the boring bar itself must be running true, otherwise it will begin hitting the face of the 3 threaded holes before I am centered over the 1/4 inch hole at the bottom. So I had to readjust the tooling and basically restart the cutting process. Had I have known that offsetting this size boring bar was not going to work, I probably would have chosen a smaller diameter boring bar for more clearance. Or better yet, stick with this bar and eliminate the boring head altogether. And that probably would have helped eliminate most of the chattering while cutting the vertical side. Alright, so a little deburring by hand and this part will be complete. The final item to make will be the lower segment side bracket. I'll be making it from 1/8 by 1 aluminum flat bar. I'm not sure what the alloy is, probably 6061. Whatever the typical stuff is you might find at your local hardware store. That's where I got this from, I believe. And I won't be spending a whole lot of time on it here. It's going to be kind of an experimental trial and error type fitment, so it might not be the final product. So yeah, just a few bends to make here in the vise, and a couple of 1/4 inch mounting holes, and I'll be doing that in the drill press. Okay, so it's now time for the all-anticipated weigh-in, where we take the payload that we'll be adding to the Osmo Z-Axis here to make it work with the Osmo Pocket 3 and compare that to the weight that it was intended for, which is the Osmo Plus gimbal head assembly. So the scale we'll be using today is a Taylor lithium, and according to their instruction manual here, it says leading the way in accuracy, and that's actually their registered trademark. So since I have no standards for the scale to confirm that accuracy, I was hoping that some 1-ounce silver coins would do the trick. As you can see, they say 1 ounce of fine silver. But as it turns out, that's not really the case. 1.1, does it say? Yeah. 2.2. And what, 3.2. It's probably borderline. Yeah, 3.3. As it turns out, these are actually using the troy ounce unit of measure. It's totally different system, so that's not going to work. So instead, what I was hoping to do is maybe go online, find out how much the Osmo Pocket 3 weighs, and we'll see if that figure coincides with whatever we end up getting on the scale here. And so let's go ahead and do that now. So I'm just going to go ahead and mask off the metric side of the specifications here, because supposedly trying to promote the metric system on people is part of the woke agenda. So to be safe, I don't know, it's true, look it up. So yeah, to be safe, we'll just be using the imperial numbers here. Let's see if I got everything. Packaging information, pounds and inches looks like. That's strange, they didn't even list any metric over there, but yeah, weight is in ounces, dimensions are in inches, temperature is in Fahrenheit, charging time, that's in hours. You know, that'd be kind of cool. You don't hear much about that, having a metric system of time. 100 hours per day, 100 minutes per hour, 100 seconds per minute. You know, that'd be kind of cool. I could live with that. It'd be handy in certain situations. But yeah, so for today, we're just going to be using the weight here of 6.3 ounces, and that's taken off the B&H website specifications for the Osmo Pocket 3, and I believe that's just for what you see here. The bare bones Osmo Pocket 3, no tripod extension handle or battery extension on it. Just the I don't know if it includes the SD card or not, but yeah. So let's take this over to the Taylor scale, and we'll see if we can confirm that 6.3 ounces. Okay, we're looking for 6.3 ounces for the Osmo Pocket 3. We'll see what Taylor says about that. 6.3 ounces. Very good. So I guess we can say that what Taylor reads coincides with what the rest of the world believes is the truth. So while we're here, let's tripod mount needs to go with it, and that will bring it to 7.1 ounces. If we're to use the extended battery tripod mount, that makes it 8.6 ounces. So it's quite a difference there. Now our goal is to be somewhere around the Osmo Plus gimbal head assembly. That's saying that's 9.4 ounces. Let's confirm that. 9.4, okay. So let's leave a note so we know, we remember what that number was. And we'll start measuring the other goodies here. The plastic cap, 0.2 ounces. The aluminum insert that goes into the plastic cap is 0.5 ounces. The top angle bracket, 0.9 ounces. Probably can't, let me shut off here. This thing shuts off pretty quick, even if you're using it. Okay, still 0.9 ounces, and I don't think we could shave much more weight off of that. But the side bracket, 1/8 by 1, and it's about 6 inches long, right at 1 ounce. And if we had to, I think we could shave some weight off of that. We could probably cut an opening here in the middle and get a lot of that off of that. Yeah, 1 ounce for that. So now we got some bolts. 1/4 28 by 3/4 with, that's a stainless, with a stainless flat washer, weighs 0.2 ounces. And we could probably go, I don't think they make aluminum in fine thread hardware, but I do have some titanium, believe it or not. But they're a little longer. They're 1 inch long, where the one we're planning to use is 3/4 inches long. And so let's see what 6 titanium, shut off again, didn't it? 6 titanium 1/4 28 by 1 socket head bolts weigh, 1, 2, 3, 6 of them weigh 0.9 ounces. Whereas the same size bolt in stainless, 6 of them would weigh, 2, 3, 4, 5, 6, 6 of them would weigh 1.6 ounces. And that's the same size as the titanium bolts, just to be fair. So yeah, 1.6 ounces. So there's quite a weight savings we could do if we went with that, although it's only working with 1 bolt, so it really wouldn't be huge. And that bolt that we are going to be using, the 1/4 28 by 3/4 with a flat washer, it goes into the insert there. It attaches basically those two together, like so. And that's its purpose. So the next bolt, a little shorter. It's a stainless 1/4 20 by 1/2 long, and it's also got a stainless flat washer, and we're at 0.2 ounces with that. So I'm pretty sure we can get those at the hardware store. Coarse thread aluminum seems to be pretty common. So what? Yeah, all right. And our last item to weigh here is the wing nut. Oh, by the way, that bolt hooks in and attaches the lower bracket with the top bracket right through that hole there, like so. And then the bottom hole goes into whatever tripod mount we're going for the Osmo Pocket. And that weighs, so that's a, yeah, that's a 1/4 20 by 1 stainless bolt, and we got a pretty heavy steel wing nut type of thing on there with it. So we could definitely shave some weight off of that if we made both of those aluminum. But that weighs, yeah, that's pretty heavy, 0.8 ounces. That's almost as much as that top bracket. So yeah, you could probably almost cut that in half by going with aluminum. So now, with everything together, let's clear this and turn it back on again. Again, our goal is around 9.4 ounces. And of course, we'd have the Osmo Pocket 3 with a tripod mount and all the goodies that go with it to make it work. Brings that to a total of 11.1 ounces. So what is that, like a 1.7, 1.6 ounce difference or something like that? So yeah, we're quite a bit heavier. If we did have to use the extended battery grip, make sure everything's on the scale here, 12.6 ounces. So 11.1 compared to 12.6, so that would be way over the 9.4 ounce goal there, but still might work. You know, you never know. All we can do is assemble it and see what happens. Alright, so everything seemed to assemble fairly smoothly. The only change I wish I would have made at this point would be to have this upper bracket be a little bit longer, maybe even like half an inch or 3/8 of an inch at least. But my hopes were to just be able to release this whole assembly that I put together from the Z-Axis by just turning the knob like you would on the Osmo Plus gimbal head. But that's not going to be the case, because once you release that knob, you still got to lift it up, straight up about 1/4 of an inch, and then you can turn it to the side or whatever to release it the rest of the way. But the way it's so close to this housing, I'm only getting about a 1/16 of an inch movement out of it. So it's not going to do it as hoped. The problem with that is that even without the Osmo Pocket 3 attached to this bracket assembly, just having this stick out so far away from the rest of the assembly the way it is, and being it's attached to just simply a plastic cap, it's probably pretty fragile. And so when I go to store it, like in a backpack for transport or something like that, I either got to be very careful with the way I pack it, or I got to take an Allen wrench along with me and simply undo the bolt that way and remove it. So yeah, a little bit more inconvenient than I hoped, but for as seldom as I'll probably actually be using this Z-Axis, it's not a big deal. Balance-wise, with the configuration you see here with a shorter tripod mount on the Osmo Pocket 3, I'm at about 9.5 turns on the adjustment knob out of 12. And so it's at the upper 3/4 amount of adjustment, but I think it should be fine. I did try the extended battery mount with it, and that made the adjustment knob have to go to about 11 3/4 turns out of 12. So it was pretty much maxed out when using the battery, an extended battery grip. But I don't really see myself needing it that much. The battery life that I get out of this Osmo Pocket 3 seems to be pretty good for the amount of time that I'd probably ever spend on the Z-Axis here. And so yeah, I think it'll be just fine. I think I have enough flat bars and extensions and threaded gizmos. Some of the flat bars in there have got 1/4" 20 holes in them. Some of them are just straight 1/4" holes. They're pretty much just leftovers, things from other camera projects, attaching microphones and DSLRs or whatever to tripods at the same time, and at different extensions and all that. But I think I got probably enough in this bundle of stuff that I can make something to attach the Osmo Pocket 2 alongside the 3 here, with one being in the Z-axis and the other on a more rigid mount beside it. And yeah, I'd be able to do a side-by-side comparison with the final video being like a split screen type of thing with the camera synchronized and everything, so we can see just exactly how much the Osmo the Z-axis would help in stabilization and stuff. So I might even let the Osmo Pocket 2 ride on the Z-axis and just be able to do a fair comparison that way. And yeah, who knows? Maybe the final footage from the Osmo Pocket 2 will actually be better than the 3 when it's attached to the Z-axis here. So the plan for that is actually to do maybe like a walking test with it, and then like a running test. And I think I got enough brackets over there that I can actually hook it up to the handlebars on my bicycle, and maybe even do like a bicycle test on that and see if it helps with that. And I even thought about hooking it up to the Bronco and doing a road test. And it's just interesting. It'll be maybe interesting to see just what the Z-axis helps on and what it doesn't. But that'll all be kind of a weather dependent thing. The way the weather is around here, lots of rain in the Pacific Northwest, and these pocket cameras don't really like getting wet very often, if at all. So pretty much got to pick my days when I want to go out and film. So might be a while before that video comes out, but yeah, until then, thanks for watching, and I'll see you on the next one.